Hi everyone, I'm Alex and welcome back to our channel. A couple of days ago my wife has been cleaning in our shed and accidentally discovered this amazing and pretty weird piece of Chernobyl history. This is called DP-64 and that was a Soviet-made nuclear fallout indicator. Pretty one-of-a-kind device, I have to say. So what I'm gonna do today is to make a review of it as well as to restore it, because we would like to turn it to a future museum exhibit. So gonna be pretty interesting. Like this video, subscribe to our channel, and don't forget that much more you will find on our Patreon page. Link is in description below. So let's go. Well, it is a long established fact that the best radiation meter is that one that will show you precisely that it is time to get out from a dangerous place. So this very thing is exactly that kind. It was originally designed to be used in the fallout shelters, so basically the dwellers will understand that it is safe to go out, or not safe. But in Chernobyl it also got pretty serious application. You probably remember that after the Chernobyl disaster there was a lot of graphite and highly radioactive waste scattered across the roofs of the Unit 3, place under the chimney and so on. And given that the robots were generally non-effective to dealing with this stuff, they decided to send their people, the bio-robots, yeah? So originally the passage to the roof, that was just a breach in the wall that later became equipped with such a bunker-like door, the same doors you can find in a bunker under the Chernobyl nuclear power plant. And exactly next to the door was placed the DP-64. Well, actually, I'm pretty sure it is still there. And by the way, on that picture there is one cool detail. So notice this Soviet robotic camera, which is mounted on this makeshift stand made out of office chair, yeah? And not so long ago I got an amazing gift, a box inside which I found exactly this type of camera, all the cables and even a control panel, and it works. So we're gonna have an amazing episode about this electronic eyes for Chernobyl disaster, so don't forget to subscribe. Okay, so now let's take a look to our hero. The device has a signalizer panel and a detector. They are connected with this fake 30-meter long cable, and contrary to usual dosimeters, this one does not have any kind of a display. Instead, there is a light bulb and a speaker. The light bulb is under such a transparent cover, which is removable, but it's actually really hard to change the bulb from outside, better to dismantle, because it sits pretty deep. So when there is high radiation detected, it starts to flash and make clicks. There are two switches, one to turn it on and another one for a quick self-test. And below there is a metal panel with operator instructions. And it says, you switch the device, then you switch it to the self-test, and then it should give you the test signal, some flashes and some clicks. Then you turn it to operation mode and it's ready. As soon as radiation contamination detected, switch off the device immediately. Okay, and then perform control for its presence by short time switch it on for 3 to 5 seconds. Pretty interesting protocol, I have to say. It has to be placed on a wall vertically, so you have all the controls in front of you. So therefore there is a wall mount, and below are the connectors for the cable, which should be covered with removable cover. And the original power cable was cut away, so you'll need to place a new one a little bit later. The device could work from 6-volt external batteries or from 220 or 127 volts, just from the wall socket. But to choose the voltage, you need to remove the cover and place the fuse accordingly in this tiny fuse box. Well, overall condition here is pretty far from good, so here is some rust, dirt and some scratches, and also some screws around and missing. So all of this we need to place back. Okay, so let's take a look inside. It's pretty easy to open. The back looks like this, and inside we have one circuit board with the familiar 3D mounted components. You can open it this way. The principle of operation is pretty simple. When the Geiger counter tube registers radiation, it will produce some impulses. That impulses will charge the capacitor. And when it becomes charged to a certain level, it triggers that neon tube, which is connected to this large relay. The relay sits in the tight socket. It's not so easy to take it out, but eventually it's possible to change it if there's something with it. So this is what it looks like. The relay switches on and then triggers the light and a speaker. The speaker, by the way, is pretty huge, and next to it there is a rotary resistor that allows to adjust the sensitivity. The lowest level on which this device will actually react is around 2 millisieverts per hour, so that's pretty high level. Okay, so now let's bring it to a little bit better condition. So as first I removed the power switch and also used some detergents to remove the flags, because there is pretty much dirt around. Then let's install a new cable. Well, it has to pass through such a rubber insulation, it had also a metal hook. All of that is rusty and not secured, and actually a part of that rubber nearly immediately fell apart upon just moving it. So I removed some rust and then attached it to a new cable. Typical to most of the Soviet devices, the earthing always has a separate external connector. But here I will do it different way and will attach an earthing wire from inside, because the screw on that connector is enough long. Then I place it back the rubber ring and place it back to missing screws that hold the cable in position. I also cleaned the rust from switches as much as was possible, and also changed the nut, because the old one looked a little bit damaged. In reality I would change the switches as well, but right at the moment I'm out of the spares. So that's what it looks like, and I believe it's not that bad. Then I soldered the wire that comes to the fuse box and covered the connection with the original plastic tube that was on the original wire. And another one that goes to the switch, I decided to solder straight to it. So I had to remove the remains of the old one and then cleaned it and placed the new one inside. So all now is pretty okay. There are two more extra wires to be used when it is connected to the battery, but for now I just sealed them, because that battery should be a little bit unusual, so there is actually no point to fix them. I don't really like these 4 rusty screws, so let's remove them and clean or maybe replace them. We'll need to dig a little. And well, this gives us a chance to look on the speaker. It looks pretty similar to those you can find in payphones, I would say, but this one is a little bit larger. It appeared that I eventually do not have any spare screws of this very length with this type of head, so I just cleaned the rust and later assembled the speaker back. Well, to my mind, looks a little bit better. And also I cleaned and placed back the light bulb cover. Okay, now let's place back the resistor that allows us to adjust the sensitivity. I have to say I'm pretty lucky that I have a few spare nuts which are specifically designed for these resistors, because they have a little bit unusual shape. And then I also secured the circuit board on its place by installing back some missing screws. So now we can close it all back. Here have to be 4 screws, 2 on each side, so let's place them back. And finally, let's attach the detector. So here everything is very straightforward, because there are 3 pins, numbered 1, 2 and 3, and there is a corresponding numbering on these forks on the cable. Yeah? The third wire is earthing, and for detector it's not that critical to have it, so I'm gonna connect just 2, because another one is just cut. And then I need to place this cover and secure it in position using 2 more screws, which are straight in the cover. And finally, let's cover back the fuse box and secure it with 2 screws. So this is what it looks like now. To my mind, not so bad as for future exhibit, and actually the device powers on, but unfortunately doesn't work really well on self-test, so I think I will later attach their small socket based on just a couple of transistors that will make that flashes and clicking. But for now I believe pretty a good result, so let me know in the comments what do you think. And don't forget to like this video and subscribe, because there will be much more in the future. Well, I think I will put some documentation for this device on our Patreon page, so don't forget to join us there. Link is in the description below. And next week we are going to have much more interesting hardware, so stay tuned. And that's it for today. I hope you like it, and see you next time.